Dear students, in this video we are going to talk about the coordination number. This is also known as the ligancy. So see here, the density of the packing is expressed in terms of the number of nearest or equidistant neighboring atoms of the atom which have taken under the consideration. It is nothing but the number of neighboring atoms or number of atoms which are touching the atom which we have taken under consideration. It is known as, or it is called as, the coordination number. So simple manner, we just keep it in mind. What is coordination number? The number of atoms which are touching the atom which we have chosen for the or which the atom we have taken under the consideration. So nearest neighbor आपको क्या करने हैं, गिनने हैं, and that number is the coordination number. See, ये नंबर जितना कम होगा उतना पैकिंग कैसा होगा, पैकिंग फ्रैक्शन क्या होगा, कम होगा. So lesser will be the coordination number, lesser will be the packing fraction. So same thing here we are going to discuss here about the coordination number for the simple cubic, face centered, body centered, and for hexagonal close packed structure that we are going to see. So take the example of the simple cubic structure. If you take this simple cubic structure, so here, so if you take any corner atom, as we know there are 8 corner atoms. So 1, 2, 3, 4. This is 5, 6, 7 and 8. Okay. So here, so if you take any corner atom, it gets surrounded by at equidistant from other 6 atoms. So see here, one is this, second one is this, third one is this. So this is the nearby cell. So this is one more here. This is on the top, isn't it? So this is on the back. Right? So in this way, how many are there? 1, 2, this 3, 4, 5 and 6. So in this way, you take any corner atom, so it is get surrounded by how many, or it is getting surrounded as well as it is getting touched by how many atoms? 1, 2, 3, 4, 5 and this is 6. Because see, we have seen that adjacent atoms are going to touch in the simple cubic structure. So it will be like this. Okay, so and this one more is here. So see, the coordination number for the simple cubic structure, you can see here, is 6. The coordination number here for simple cubic structure is 6. Now in same fashion, if you see for the body centered cubic structure, so there is one atom at the interior of this cell, isn't it? So this is the atom at the center, and which is touching this all the 8 corner atoms. And one is at this back. Okay. So one is, you can show here. So like that, the coordination number for this body centered cubic structure is how much? 8. The coordination number for BCC is equal to how much? It is 8. Okay. Now if we see the different types of packings, so how are the packings? We are having one dimensional packing, or let us now discuss before going for the seeing of the coordination number for these FCC and this HCP. Let us see here the packings, various packings. So we are having one dimensional, two dimensional and three dimensional packing, isn't it? So in one dimensional packing, if I take this one dimensional packing, how the atoms are arranged there? In one direction only. Say the atoms are arranged like this only in, suppose this is x direction and this is y direction, so we can see only along x direction the atoms are arranged. So in one dimensional packing system, if you take any of the atom under consideration, then tell me what is the coordination number for this. So any atom you take, it is getting in touch with the neighboring two atoms. So for one dimensional packing, the coordination number is how much? Is 1. Isn't it? Now, if I take the second packing, that is the two-dimensional packing. So this two-dimensional packing is now having the type A, that is square, two-dimensional square packing, and the B is the two-dimensional hexagonal packing. Now see here, in 2D square packing, I write here 2D square packing, how these atoms are arranged. Now see, here we have arranged the atoms only in x, one direction. Now here 2D, that is we will also arrange the atoms in y direction. So how it will look like? So if these are the atoms in one direction, so 2D, so go in the y direction. Like this, okay? This is the two-dimensional square packing. But when you go for two-dimensional hexagonal packing, how the atoms are arranged here? See here. So, see the difference. So this is the one line of the atoms. Now here, see here how the atoms are arranged. So, 1 over above, in that fashion we have arranged the balls or these atoms, which is not so much stable, isn't it? So ek ke upar, this is one line, on same line, in same manner we are keeping these atoms. Okay, so compared to this hexagonal packing, this is quite loose packing. It is not stable. Okay, but see here how I can make this packing stable in hexagonal packing. So see here, I am going to put the next layer of the atom. How? To just that sit, the atom will sit on the space between these two. Okay, so see here, now the atom will be sit here, more stable, isn't it? So like this we are getting this two-dimensional hexagonal packing. This is two-dimensional square packing, 1 over the above. Now for this kind of packing, if we want to find out the coordination number, see here. So if I take any of the atom under consideration, so how many neighboring atoms or touching atoms? So see, this is 1, this is 2, this is 3 and this is 4. Okay, and if I join this, so it will be square, isn't it? So that is why this is known as two-dimensional square packing, whereas here if you take any of the atom here, okay, for example I am taking this, and see how many nearest neighbors. So this is 1, this is 2, this is 3rd, this is 4th, 5th and 6th. So see the two-dimensional, the hexagonal, why they are saying the hexagonal? See, because any atom we take under consideration is touching the 6 neighboring atoms. Okay, so for that the two-dimensional hexagonal packing is having the coordination number is how much? This coordination number here, 2D hexagonal packing is 6, whereas for 2D square packing the coordination number is how much? 1, 2, 3 and 4. 1, 2, 3 and 4. This is the, okay, so we have seen this 1D packing, 2D square packing, 2D hexagonal packing and corresponding coordination numbers for these. Dear students, let us see the 3-dimensional packings, and in that we will see the coordination number for the 3-dimensional square packing, the HCP and for FCC. Let us see this 3-dimensional packing system, which is the stacking sequence is there. So there are 3 sequences, A, then we are having AB, and the third one we are having ABC, like that. So what does it mean? So see here, so here every layer is same as that of the first layer, that is all layers are same here. If you see here, the first layer is layer A, then the B layer is different from the A, and again on that we are having this A layer. Okay, so after every 2 layers this first layer is repeating, and again see after first layer again the second layer is repeating. So like this, here see we are having 3 layers A, B, C. Okay, so after this 3 again the first layer is repeating, like that you are having this stacking sequence. So in 3-dimensional packing we are having this 3-dimensional square packing, and this is the hexagonal closed pack structure HCP, and this is the face centered cubic section in 3-dimensional. Okay, now see here, if you look at this, here the first layer is A, of course this is square packing. So here this layer is the 2-dimensional square packing की जो हमने layer देखी थी, it is like that only, but here in 3-dimensional how it will be, I am drawing here. So this is what the basic 2-dimensional square packing, but here we are seeing the 3-dimension. So suppose in the box we have kept these atoms or balls, and now this is the intermediate layer, one of the random intermediate layer. So definitely अगर मैं बीच से ये उठाऊंगा layer को, so of course उसके पीछे भी कुछ होगा and उसके आगे भी कुछ होगा, isn't it? So one layer is backside of this layer and one layer is above this, that I can show with this red pen. Say, so these are the atoms on इस साइड में जो है, और एक लेयर उसके पीछे भी है, isn't it? Like this. So now it becomes the three-dimensional square pattern, isn't it? Now same, it is behind this black color, isn't it? So tell me, if I select any of this atom and if I want to know the nearest neighbors for that, coordination number मेरे को जानना है. So see, if I take this atom as an example, see, so basically चार एटम तो क्या कर रहे हो, उसको टच ही कर रहे हो. दिस इज 1 2 3 4. इन एडिशन टू दैट इट इज थ्री डायमेंशनल. सो एक जो है दिस इज फिफ्थ, जो इस साइड से टच कर रहा है, इजंट इट, बाहर की साइड से, एंड वन इज फ्रॉम बैक साइड टचिंग दिस एटम. सो व्हाट इज द कोऑर्डिनेशन नंबर फॉर दिस? इट इज 6. Please remember, for three-dimensional square packing, the coordination number is always 6. Now come to this. Now here, please remember, for these two, HCP and FCC, for AB packing and for ABC packing. So for these two, ये जो A वाली layer है, this A layer will be same for these two, that is it will be two-dimensional hexagonal layer. Please remember, ये जो A layer बनने वाली है दोनों के लिए भी it is what? Two-dimensional hexagonal. So it will look like this. So A layer is going to be like this. We know that this hexagonal packing is more stable than this square packing, because see here, the arrangement is like this. They are stacked like this, isn't it? So see here, as for both these packings, for HCP and FCC, so this A layer is same for both of these. HCP and FCC के लिए क्या होगा, ये जो A layer है, this is the basic layer for these 3D HCP and FCC. So A layer हो गई. Now we have to see for layer B, and in FCC again there will be one layer C. Now see here, again let us consider that we are having the box. In that box we have arranged the layers of the atoms like this, okay, and one by one we are stacking the layer. Now what happened if I take the any layer which is somewhere in the middle of this arrangement? So definitely when I am seeing this layer, so wherever these are the voids are there, isn't it? From these voids I can able to see the top of the atom which is below these three atoms, isn't it? So these are the voids, isn't it? Through these voids I can see the top of the atom which is below this, when I am taking the layer in between, not directly from the bottom, but somewhere in the middle. If I take this layer in this HCP जो भी हमने sequence लिया है, then definitely this void is nothing but we can see here the top of the bottom which is below it, isn't it? So I am showing it with the red pen. Now what thing we are going to do here? So see, whenever there are three atoms are there, because of these three atoms, whichever void is created, it is known as triangular void, isn't it? Triangular void. Now see, this is the void is created due to how many atoms? This 1 2 3 and उसके नीचे वाला 4. So whenever this void is created because of these 4 atoms, this void is known as the tetrahedral void. The tetrahedral void, isn't it? So same thing we are going to do it here. So whichever these tetrahedral voids are there, we are going to cover it by the second layer, that is the bth layer. ये जो B layer इसके ऊपर जो आने वाली है, because this sequence कैसा है इसका A B. So here for this layer B, what we are going to do? So whatever these tetrahedral voids are there, I am going to cover it. Okay, how I can cover that voids? So let us see here. I am covering these voids like this. Okay, so see here, this blue layer, blue plane layer जो atoms मैंने बिठाए यहाँ पे, so they are all covering what? The tetrahedral voids, isn't it? Like this tetrahedral voids, how? 1, 2, third atom, okay, so this is the tetrahedral void here. See, this is the tetrahedral void. Now I am going to cover this void with this atom. Okay, with this atom. Now this is which layer is formed above this layer A is our layer B. Okay, so all the tetrahedral voids are getting covered. So this structure is our 3D HCP having the sequence AB. Okay, so AB. Now जो इसके बाहर ऊपर जो और एक लेयर आएगी कौन सी होगी? आफ्टर A is completed, B layer is completed. Now same like this black, once again there will be this third layer of again same as that of layer A. So this is the stacking sequence for this HCP. And very easily we can calculate now. We are interested in what? We are interested in the coordination number for the HCP. So see, if I take this atom for the consideration, under consideration, so already it is two-dimensional hexagonal close packed structure है. कौन सा? A layer का. So definitely 6 atoms तो already क्या है इसके टच में है. This is 1, this is 2nd, this is 4th, this is 5th and this is 6th. 6 atoms are already in touch with this atom. And remaining are what? See, these 3 are touching here 1, 2, 3 from the top. और इसके पीछे भी होंगे तो इसके जस्ट पीछे A के पीछे कौन सी लेयर होगी? फिर से B लेयर होगी, isn't it? So ये 3, 6 और 3 9 और जस्ट इसके पीछे भी क्या है? ये 3 ऐसे है, isn't it? Which are touching this atom. So total how many? So total 12 कितने? 12 atoms. So coordination number for this hexagonal close packed structure is how much? 12. Please remember कितना होता है? HCP के लिए coordination number जो रहता है कितना रहता है? 12 रहता है. Okay. And one thing here, see, this is the tetragonal void. Yes or no? This black atom is covering this tetragonal void. So if the atom which is present inside this tetragonal void, so what is the coordination number for this? So of course this atom is touching all these 4 atoms. So coordination number, the atom which is present in the void of this tetragonal void is 4. Okay. So this is the thing about HCP. Now in same we can see the FCC. Now see, we have got here layer A, layer B. Now just if you add here layer C, then this structure is ready for the face centered cubic structure with the sequence ABC, ABC, ABC. So here A layer is already there, B layer is already we have plotted. Now we have to see for the C layer. So see here in this diagram, whenever we are going to cover, अभी हमने tetrahedral voids cover कर दिए पूरे. Now same figure, if I am covering all the octahedral voids, see octahedral voids, if I am going to cover it, isn't it? Then see, I am going to cover the octahedral void. कैसे बनती है octahedral void? So it will form like this: 1, 2, 3, This is 1 2 3 कुल मिला के 6 एटम्स को मिलके जो वाइड्स बनती है, देखो सी दिस वाइड. So 1 2 3 4 5 6 1 2 3 4 5 6, including these 6 atoms, the void which is created, it is the octahedral void. Now let us see here where it is. So see here, this 1 2 3, this 1 2 3. So where is this octahedral void? So octahedral void is here. See, I am covering it. See here, 1 2 3 1 2 3 6. ये जो void दिख रही है, this is the octahedral void. I am covering it with the red pen. See, 1 2 3 1 2 3. This is the octahedral void. I am covering it. 1 2 3 1 2 3. This is the octahedral void. This is the octahedral void. Okay, so this red pen is showing us the C layer or layer C, isn't it? So in this structure, if I am going to cover all the octahedral voids, then your structure is become this FCC with the sequence ABC ABC ABC. And of course, if you look at the coordination number for FCC also, if you draw this diagram nicely and calculate, you will find it once again. It will be coordination number, it will be 12. It will be 12 again for the FCC. Please remember this. Very, very important. Okay. So if I draw this diagram by keeping some space between these atoms, so it will look like this. See, this is 1 3 4 HCP 2D HCP निकालना पड़ेगा. Intentionally I am having this huge space so that you can get the idea. Now where it is the tetrahedral void, for this is layer A is over. Now where is tetrahedral void? So this is the bottom atom somewhere here. So this is tetrahedral void जो 4 एटम से मिलके बनी है. This is the tetrahedral void. This is the tetrahedral void. Okay, I am going to cover it with the blue pen. So this tetrahedral void is covered. This tetrahedral void is covered here. So this is B layer completed, and for C, isn't it? So this void, see here, I am showing this void, octahedral void with this letter O. So you see 1 2 3 1 2 3 1 2 3 1 2 3. So these are the void. So this void I am going to cover with this red pen, isn't it? So in this way, so this is again tetrahedral void is there, tetrahedral void is there. So like that you can go on identifying these tetrahedral voids, cover it, then find out the octahedral voids, cover it, you will get this is the C layer. In this way we can able to find out the number of nearest touching atoms, nearest neighbors. In this way we got this coordination number for HCP is 12, and it is for the FCC it is also 12. What is the stacking sequence? How layers are stacked one above the other? In HCP, AB, AB, AB. In FCC, ABC, ABC, ABC. So in this fashion, in this video we have seen the coordination number are nothing but what? The nearest neighbors for the any atoms which I have taken under consideration, and we have seen for the simple cubic structure it is 6, for body centered cubic structure it is 8, for 2-dimensional square packing it is 4, for 2-dimensional hexagonal packing it is 6. Now Just now we seen in 3 dimension we are having the sequences where 3D square packing is there. 3D square packing, the coordination number is how much? It is 6, and for HCP and FCC it is 12. Very important. Thank you.